Have you ever stopped to think about what separates, say, a skyscraper that's designed to sway in the wind from an engine block that has to withstand insane amounts of heat? Well, get this. The answer lies in one powerful family of materials. Today, we're going to decode the secrets of the iron family, and you'll see pretty quickly why our world, well, it just couldn't exist without them.
So what's the deal with that? Why the huge difference? I mean, both are super strong, and they're both fundamentally made of iron. But one needs to be flexible, right, to handle the wind. The other has to be incredibly rigid to contain thousands of tiny explosions every minute. The answer isn't just iron, it's all about how that iron is prepared.
And that's exactly what we're going to explore today. All those crucial differences, they exist within one single powerful group, the iron family. Or, if you want to use the engineering term, ferrous metals. Okay, so to really get a handle on the iron family, we got to zoom out a bit first and look at the bigger picture. Kind of like a family tree for materials. All right, so right at the very top of our tree, you've got this huge category called engineering materials. This is the big one. It's the master category for basically everything used to build, well, anything you can imagine. It really is the ultimate toolbox for an engineer.
Okay, let's take one step down that tree. We land on a really big branch, metals. We all know these guys, right? They're strong, they conduct heat and electricity, they're pretty much everywhere. But here's where the family tree splits right down the middle.
And boom, that brings us right to the heart of our topic today, ferrous metals. Ferrous sounds complicated, but it's really just a fancy way of saying it's got iron in it. And in this iron-based family, there are three main players we absolutely have to meet: cast iron, wrought iron, and of course, the superstar of the group, steel. Okay, so let's start with the two OGs of the family, the elders, if you will. These are the materials that literally laid the foundation for the entire industrial world: cast iron and wrought iron.
First up, let's talk about cast iron. So what's its deal? It's an alloy of iron with a lot of carbon. We're talking between 1.7 and 3%. All that carbon makes it incredibly hard, and it gives it amazing compressive strength. That means it's fantastic at resisting being squashed. But, and this is a big but, that hardness comes at a price. It's brittle. It doesn't bend, it shatters.
But wait, it's not that simple. Not all cast iron is the same. It's kind of like a mini family all on its own. For example, in gray cast iron, the extra carbon forms these tiny little graphite flakes. This makes it really easy to machine, which is exactly why it's perfect for something like an engine block. Then you have white cast iron. Here, the carbon forms something called iron carbide, which makes it super hard and wear resistant, perfect for things like rock crushers. And finally, there's malleable cast iron, which gets a special heat treatment to make it tougher. You'll find that in stuff like wheel hubs. All right, let's shift gears and meet the other elder, wrought iron. So if cast iron is the strong, brittle traditionalists, then wrought iron is like the flexible artisan of the family. I mean, just look at that purity. It's about 99.5% pure iron. That purity is what makes it so tough, malleable, and ductile. You can heat it up and hammer it into all sorts of shapes, which is literally what the word wrought means, worked or shaped. So, putting them side by side really shows you the core difference, doesn't it? Cast iron, the high-carbon alloy, is hard, but brittle. Give it a sharp whack and it can crack. Wrought iron, which is almost pure iron, is tough and ductile. It'll bend and lets you shape it. The one thing is, wrought iron isn't great with sudden shocks. That's why you see it used for things like ornate railings or chains, things that need to bend under a steady force, not shatter from a sudden impact. Okay, so we've met the elders, but now it's time to meet the most famous, the most important, the most versatile member of the entire iron family. I'm talking about the one that truly defines our modern world. Let's talk about steel.
So what is steel, really? Well, it's also an alloy of iron and carbon, just like cast iron. But here's the crucial difference. It's all about the amount of carbon. Steel has less than 1.7%, and that puts it in this perfect sweet spot right between the brittleness of cast iron and the relative softness of pure wrought iron. It's this amazing balance that makes it so unbelievably versatile.
And for the most basic kind of steel, what we call plain carbon steel, it really is that simple. Pretty much all of its properties, its strength, its hardness, it all comes down to one single thing, that carbon percentage. And you can see that relationship crystal clear right here. As the percentage of carbon goes up, so does the strength. Low carbon steel is a bit softer, way easier to shape. But high-carbon steel? That stuff is incredibly strong and hard, which is why it's perfect for things like cutting tools or knives. It's a simple, elegant trade-off, really.
Okay, but what if you need more than just strength? What if you need your steel to, I don't know, resist rust or stay hard even when it's glowing red hot? Well, that's when we get into the really cool stuff, creating what I like to call designer steels. The answer is to create an alloy steel. And this is where engineers really do become like master chefs. They start adding tiny amounts of other metallic elements into the iron and carbon mix, and each new ingredient gives the final steel its own specific superpower.
Yeah, you can really think of this like an engineer's spice rack. You need to make the steel tougher, you add a dash of nickel. You want it harder and more resistant to wear and tear? You throw in some chromium. What if you need a drill bit that stays hard even when it's scorching hot from friction? You add tungsten. See? Each element is like its own superpower in a bottle. Now, the most famous alloy steel of them all is, of course, stainless steel. Its superpower is fighting off corrosion, and it gets that power from a healthy dose of chromium and usually a little nickel too. What happens is that chromium creates this invisible protective layer right on the surface that literally stops rust dead in its tracks. You've probably seen this number before, 18/8, stamped on your kitchen sink or your forks and knives. It's just a common shorthand for one of the most popular types of stainless steel out there. All it means is that the steel contains 18% chromium and 8% nickel. That's it. It's the recipe for a tough, shiny, and rust-proof material.
Okay, so with all these hundreds, even thousands of different recipes for steel, how on earth do engineers keep track of them all? Well, they came up with a system. It's kind of like a secret language, a code that tells you exactly what's inside a piece of steel just by looking at its designation.
Now, there are a few different systems out there, but today we're going to crack the code on a really popular American one, the SAE system. That stands for the Society of Automobile Engineers, and trust me, it's way simpler than it looks.
It basically breaks down into 3 simple parts. Ready? Step 1, the very first number tells you what the main alloying element is. Step 2, the next digit, or sometimes 2 digits, tells you the percentage of that main alloy. And finally, step 3, the last 2 digits tell you the carbon content. You just have to remember to multiply it by 0.01, or easier, just imagine a decimal point in front of them. So if you see a 40 at the end, that means 0.40% carbon.
All right, let's end this with a little challenge. Let's say you see this code, SAE 71360. Based on what we just learned, can you decode it? Let's do it together. The first digit, 7, tells us the main alloy is tungsten. The next part, 13, tells us there's 13% tungsten in there. And the last 2 digits, 60, mean it has 0.60% carbon. And just like that, what was just a meaningless string of numbers now tells you a complete story about that specific steel. So from skyscrapers to kitchen forks, you can see that understanding the iron family is really about understanding the language of our modern world. Thanks so much for tuning in.